Afternoon, guys. I've been asked a few questions by some students, and I felt I should just try and give some clarity on this. When you're doing collects, guys, okay, um, collects, they are almost like we could call it a data capturing, because what you want to do when you're calculating quantities for a whole building, there is a certain there's a certain uh, dimensions and quantities that you'll be using. There's certain heights, there's certain perimeters that you'll always be using when you're calculating from all the elements, from foundations up until superstructure. Okay, so one of those we call the center line, which is it's from the perimeter. When you've got a perimeter of a wall, which is the perimeter only speaks about the external of your wall. So if this is your wall like this, and let me get another pen. If this is your house, okay, sorry about that, and that's your internal, and then you've got maybe say 6 meters here and 5 over here. This only speaks about the external part. This here, that 6 meter only speaks to that. If this is, for instance, let's say 5 over here and 4 over here, so which is, we want to know the center. We don't want to know the external. We want to know the center line of the brick wall. Okay, so that's what we need to do. So in a simple square or rectangular shape, quite simple. So if you've got a shape where you've got 12 meters by 7.54 meters, it's a rectangle. It's quite easy. So you'll only just say 12 times 2, which gives you 24 meters, and then you'll say 7.54 times 2, that would be 15.8, and you add that and you'll get 39.08 meters. Okay, but that doesn't give you the center. It gives you the external, gives you the meterage around the structure. Okay, so the reason we want to be as accurate as we can be, so we need the center of our brick wall. Okay, guys, now in order for us to do that, there's a few steps we must follow. Okay, first of all, when you are doing your collections, when you are calculating for your center line, there's a few steps you need to follow. First of all, when you're taking off your dimensions from your drawing, the length that you first start with is horizontal. Then you go with the vertical. Okay, guys, I'm going to explain to you what that means. If you go to your standard system, the standard system tells you this. It says dimensions. It says dimensions shall follow as far as possible the given following sequence. First dimensions are horizontal at right angles to your line of sight. Second dimensions are horizontal but parallel to your line of sight. And the third ones are vertical. Vertical means depth or height. Okay. But now you should ask yourself, when they say horizontal but at right angles to your line of sight. So if you are looking this way, okay, let's say you are looking at this, and there's also something like this. So if this is your eye and you are looking that way, what is parallel to your line of sight? It means this dimension here, if this is 6 meters, this is parallel to your line of sight, and this is at right angles to your line of sight. So which ones do you start with? You start with the ones that are parallel, because the standard system tells you that horizontal at right angles. Sorry about that, guys. The first one is horizontal at right angles to your line of sight. So this is the first one we take. Okay, the ones that are at right angle to your line of sight. That's the first dimension. So if you had something like this with a 7 meter here and a 6 meter, you first take this one. this dimension. And then you come to the second one, which is your parallel. So when going to your drawing, let's go to a drawing. If we look at this, you see guys, if you are standing over here, if that is your eye and you are looking that way, which one is at right angles to your line of sight? Which is, it will be this. This is right angles to your line of sight if that is your line of sight. Okay, so you need to take off these dimensions first. Okay, and remember, in South Africa we start from top to bottom, so you need to add up all of these, but let's follow what the book is telling us, the sequence that we must do. It says, let me go back to this page. The sequence is this: identify the dimension. Okay, that's what you must first do. Then write it down and then color it in. So it means here, what you would do, you would start from left to right, and then you start from top to bottom. What is your first dimension that you see over there? That is 230. So you write 230 down on your dimension paper, and then you go to the next, and then you color that part in, that 230. You go to the next one, 4900, and you color that section in, and then you write it down, then you color that section in. So it's basically identify, write down, and color. You get to here, you see 110, you write it down, you color 110, and then that's the sequence you must follow: identify, write down, color in. So as much as you could do that just by adding up all of this, you can add up all of these dimensions to just get an overall dimension, because that's what you are headed to anyway. So that's the sequence that you must take: identify, write down, color in. So you start from top to bottom, left to right. Okay, that will give you the first horizontals at right angles to your line of sight. Okay, after you do that, you come to this part. Sorry, not this one. You start from left to right. So you do this one, then come here, do this one, 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 do this one. Okay, guys. Then you will have all your horizontals, and you add your horizontals together. And remember, you must separate the thicknesses, because here on this drawing we have a 230 and 110 inside, 110 partitioning walls. Okay, guys. So after you do that, now you check which are your dimensions that are parallel to your line of sight. So if this is your line of sight, and that's the direction you are looking, what is parallel to that? It's this. These are the parallels. So again, left to right. So you start by here, identify the number, write it down, color, identify, write the number, color, so on and so forth. And whenever there's overlaps between the dimensions, because you see here over this 230, you also have a 230 this side, you have it over 230 this side. Those ones, they are overlapping each other, so it becomes an X, guys. Okay, take all of this in that sequence, and then you get the X. But you'll notice here, some of them don't overlap each other. Okay, some of them, it just goes one way, and then you are left with nothing. So those blank parts, because you don't have another dimension, just become 0. Okay, whenever you are shading with your coloring marker, and then another shade goes on top of another, then it becomes an X. Okay, so you take this one, take this, take this, take this, take this, take this, take this, take that. Then you've got what we are saying now is you've got your verticals. Okay, guys, the total that you get on your verticals plus the total you get on your horizontals will give you a total perimeter, guys. And just please bear in mind, it's not the center line, it's not the center of the brick, it's the outer part where you're going to plaster. So what we want when we're doing brick, when we're calculating for excavations, footings, foundation, brickwork, superstructure, we want the center line. Okay, so let's go back to this page here. Here, once you've got all of those, it tells you here that now after we've done all of that, we need to deduct the actual movement of the perimeter, okay, of the external angles, which deduct the actual movement of perimeter line for each external angle net, which will be in all cases, irrespective of design and layout, will be 4. This means, guys, even if you have an irregular shape with many turns and twists and recesses and all of that, the corners of your building will always remain 4. Okay, guys? So whenever you need to deduct for the center line, it will always be 4. Okay, guys? Please just note that, okay? You'll always say by 4. So this is how you do it. After you've added your total of your horizontal and the total of your verticals, you get the center, the cross center line. Then you must deduct what they just said now. So which is, it will always be 4, which is 4 means what? It means the 4 corners of the building. Because we are saying the building will always have 4 corners. And we say by 2, okay? And then by half, okay? The reason we say by 2, we say 2 walls are connecting in the 4 corners. So these corners, there's 4 corners of a building, but there's 2 walls coming towards each other. Okay, guys? So this is what we mean. There's this wall, and then there's this wall. So this represents the 2 over here. This 2, okay? And then this corner is one of the 4 corners of your building, and half means we want to come to the center. When we say half, it's because we want to come to the center of our line. Okay, guys? So please, even if you have a 270 wall, it will be 4 times 2 times half times 270. Always. Then you deduct it from your total of what you've worked out, your cross center line, guys. Okay? That will give you your middle center line. This line that we're looking for. That line we're going to use in foundations, footings, foundation, brickwork, superstructure, etc. Okay. When it comes to the internal walls, guys, it's quite simple. An internal wall will always be the same dimension. Okay. Let me just make an example for you so that you get it. Guys. Let me search for a drawing, a proper one that's got internal walls that I can show you. You see, guys, from here to here, okay, this is our internal wall. It will always be 7,400, even if you are from this side or from this side. So you don't need to calculate it. You don't need to deduct anything to get to your center line about that, guys. Okay, it will always be the same, unless it is skew. If it's the skew wall, then this side will be longer, this one will be shorter. Okay, when you want to see if something is out of square internally in your building, that's what you must check. It must always give you the same dimensions from here to here, even if you are from this side or this side. Okay, guys? So it's quite simple. In this one, you just take off all your horizontals first, which are at 90 degrees. Same concept as we did in our 230 wall. You take off these first, okay? These horizontals. Then you come to the verticals, take them off and add them all and total them out, guys. Now, when we come to this subject, there's some things that we call T's. Okay? If you can see, I've annotated the T because it comes here and makes a T with this external wall. It comes here and makes a T with a 110 wall. It comes here and makes a T also, and also a T. Okay, so you need to identify where your walls collide, because what we've got foundations, guys, running through this place. This is the foundation, because this wall, as much as it's a internal wall, it's a load-bearing internal wall. Okay, there's foundations. Remember, your brick wall rests in the center of your foundation. This is the example I've got for you. You should buy Mr. F. Bice's book. It shows you clearly. For instance, this is what's this type of wall? Okay, we've got a 230 wall, and I'm assuming this is a 110 wall. But the point is this: when you did excavation for the 230 wall, yeah, you did excavate already this part. But remember, your wall, your 110 wall, when you measure it, it comes and butts against your 230 wall. But now this space, when you measure the internal walls, you measure from here to here. But now when you're doing excavations, you're calculating excavations, remember this part we have already excavated. That's what we say deduct T's or add wall ends. Okay? So we need to deduct this section. How do we do that? We need to say the width of our foundation, let's say is 700. We need to say 700 minus 230, okay, divided by 2. That gives us 235. So we know that from here to here is 235. And we know the width of our internal foundation for the internal walls is 600. So what do? We say 600 times 235 times the depth of our trench over here. The depth will always be shown from your calculations because it's given in your specification. So it's always a three-dimensional. So you need to, when you're doing excavations, you need to deduct T's. And when there's just a wall end, maybe a wall is just ending in nowhere, you need to add this piece here. Because that part, this wall will not just rest at the end of this wall. You need to have a foundation that goes up. So it will be the same 230, 235 by 600 by the depth of the 600 foundation. Okay, the internal foundation. If that's where the wall ends. Okay, right. I'm hoping you will have some questions, because if you've got some questions, I hope guys please buy some data, because I really want to stress how this concept works. Okay, this is how it works, guys. This is the foundation of the internal wall. Okay? We are saying you've already excavated here. This is what we are saying. Here's the excavation for your trench for your internal wall. But the point is this: when you excavated here, we had already excavated this part where the internal wall goes in. So we're saying deduct this piece because you already calculated it. Otherwise, you're going to have an over measurement. Okay. So let me give you a nicer sketch that shows you in more detail. You see, this wall over here, this is a 280 wall with a different foundation. Okay. It's a 700 foundation. Okay. So this one is less than this one. But when we excavated here, the pink part, we excavated for this wall, this entire wall. So we already took out some soil. So when you excavate for this wall that's coming here, there's nothing here for you to excavate. So you can't count, otherwise we'll have an over measurement. Okay, guys? We don't want an over measurement of soil, right? So wherever you get a smaller wall butting to a big wall, you'll get the T's. You can even get it in the same walls, in the same size walls where they are making a T. That you can't over measure where you have already excavated. Hence we say deduct T's. So deduct T's essentially means deduct this soil. This soil, you need to deduct it because you have already excavated it on this side. Guys, I hope this explanation I'm giving you about collects is clear. Okay, please bear in mind, even if you have an irregular building, you've got so many recesses, and when we join that building together, it will always form four corners. I'll show you what I mean. If we take this and take it all the way like this here, and all the way like this, and all the way like this, and all this will be always four corners. That is the essence of what we're trying to say to you, that you don't need to deduct more as in, because try and add up all the corners. How many? A building will always have four. We design around four corners, okay, as much as it might have recesses. But if you add up this number and took this wall here, add this number and took this wall here, that will make a corner over there. Okay, so whenever you do a centerline calculation for external walls, it will always be 4 times 2 times half times that thickness of the wall. Deduct that from your pyramid. Okay, guys, thanks. Please drop me a message if you need more clarification, but I hope this will give you a bit of direction. Please get yourself a standard system, because once you don't have a standard system of building works, you're not able to comprehend what we're talking about. And when we say this is the sequence of how to calculate stuff. If you don't have your module 1 from first year, please say so, then I can take pictures for you and send it to you. Okay, thanks guys.